Hi everyone, in this video we are going to discuss about how to find the distance between the orthocenter and the incenter of a triangle. Let's suppose we have a triangle ABC, as you can see in the diagram, where the angle BAC is denoted by uppercase A radian, angle ABC is denoted by uppercase B radian, and angle ACB is denoted by uppercase C radian, and also the side length AB is denoted by lowercase c units. Side length BC is denoted by lowercase a units and side length AC is denoted by lowercase b units. Also, the circumradius of this triangle would be denoted by uppercase R and the inradius of the triangle will be denoted by lowercase r units. So first I am going to draw a couple of angle bisectors to locate the incenter for this triangle. And let's assume that the incenter is the point I here in this diagram. Next, I am going to draw a couple of perpendiculars from two vertices to find the orthocenter. And let's assume that the point H is the orthocenter for this triangle. And in this video, we are going to see how we can calculate the length of HI, the line segment HI, which is the distance between the orthocenter and the incenter of this triangle. From previous videos, we have seen that the distance between the vertex and the orthocenter can be expressed as 2 times the circumradius times the cosine of that angle. So for example, if we are talking about the distance of the vertex B from the orthocenter, which is HB, that will be equal to 2 times the circumradius of this triangle times cosine of the angle B. I have already created a video on this topic. I have shared the link in the description. Feel free to watch that video. Also, in another previous video, we have seen that the distance of the vertex from the incenter can be expressed like this. It would be 4 times the circumradius times the product of the sine ratios of half of the two other angles. Like in this case, because we are talking about IB, it would be 4 times R times sine of C over 2 times sine of A over 2. Also, we have seen that the inradius can be expressed like this. It is actually 4 times the circumradius times sine of A over 2 times sine of B over 2 times sine of C over 2. I have already created videos on these topics. I have shared the link in the description. Feel free to watch them. In order to find out the length of HI line segment, we have to utilize the triangle HBI. So we are going to use that triangle because we know the two side lengths, the HB side length and the IB side length, and also we can somehow find out the angle between those two sides, I mean the angle HBI, and if we can somehow find that angle, then we should be able to use the cosine law on this triangle HBI. So let's try to find out the angle HBI. If you look at the triangle ABE, that is a right triangle because BE is perpendicular to AC. So triangle ABE would be a right triangle. That means the angle ABH or ABE, that angle will be 90 degree minus A, because if you think about it, the sum of that angle, the angle ABE and the angle BAE, their sum would be 90 degree, and we know that angle BAE is actually the angle A that we denote with uppercase A. So angle ABH will be 90 degree minus the angle A. And that's exactly what I have noted here. And also if you think about the angle ABI, that will be half of the angle B because BI is the bisector of the angle B. So angle ABI will be B over 2 or half of B. And now if we subtract angle ABH from angle ABI, that will give us the angle HBI. So we can say that angle HBI is equal to angle ABI minus angle ABH. And if we plug in the values, it's going to look like this. It would be B over 2 minus pi over 2 minus A, because angle ABI is equal to B over 2 and angle ABH is equal to pi over 2 minus A. So I simply plugged in the values and it's going to look like this. And we can write it as B over 2 minus pi over 2 plus A. We simply remove the parenthesis, so it's going to look like this. Now in place of pi over 2, I am going to write A over 2 plus B over 2 plus C over 2. Because we know that for a triangle, the sum of the interior angles is equal to 180 degree or pi radian, and half of that would be 90 degree or pi over 2. So we can say pi over 2 is essentially equal to half of A plus half of B plus half of C. And that's exactly what I have done. I have kept the positive A up front, and then I have the positive B over 2, and then minus wherever I had the pi over 2, I have noted A over 2 plus B over 2 plus C over 2. Now we are going to remove the parenthesis and then it is going to look like this. And here you see that positive b over 2 and negative b over 2, they will cancel out each other, and also we can subtract a over 2 from positive a. So we are going to be left with a over 2 minus c over 2. So we have been able to calculate the angle HBI. So now our life is easy because we have been able to find the angle between HB and BI. We should be able to use the cosine law on that little triangle, which is triangle HBI. So let's do that. If we use the cosine law on this little triangle HBI, there we can say that cosine of the angle HBI will be equal to HB squared plus IB squared minus HI squared over 2 times HB times IB. And if we plug in the values of the angle HBI and the side length HB and the side length IB, then it's going to look like this. And here the only unknown is HI, and that's exactly what we need to calculate here. So what I'm going to do, I'm going to cross multiply the denominator with the left hand side, and then it's going to look like this. And next I'm going to bring the HI to the left hand side and bring the left hand side quantity onto the right hand side. So it's going to look like this. In the next step, I'm going to expand cosine of A over 2 minus C over 2, and then this right hand side expression is going to look like this. And this expression is actually equal to HI squared. So first we'll calculate the value of HI squared, and then finally we'll take a square root on both sides, and that will give us the value of HI. In the next step, I'm going to remove the parenthesis on the right hand side, and then we're going to write it as individual terms like this. Now if you look at the second and the fourth terms, we have a nice common factor there. The common factor would be 16 times r squared times sine squared of c over 2 times sine squared of a over 2. That will be the common factor between the second and the fourth terms. So if you take that common factor out, then it's going to look like this. In the next step, I'm going to replace 1 minus cosine of b with 2 times sine squared of b over 2, because we know that cosine of b can be written as 1 minus 2 times sine squared of b over 2. And from here, if you think about it, 1 minus cosine of b can be written like this. Also, I'm going to do another thing. On the rightmost term there, we're going to combine 2 times sine of c over 2 times cosine of c over 2. That will become sine of c, and similarly 2 times sine of a over 2 and times cosine of a over 2, that will become sine of a. So that's exactly what I'm going to do in the next step. So here you see that I have replaced 1 minus cosine of b with 2 times sine squared of b over 2, and wherever we had 2 times sine of c over 2 times cosine of c over 2, I have replaced that with sine of c, and also 2 times sine of a over 2 times cosine of a over 2, that has been replaced with sine of a. In the next step, I'm going to play with the second term here. I'm going to create a whole square of the value of Inradius. So I'm going to make it 4 times r times sine of a over 2 times sine of b over 2 times sine of c over 2 whole square, and see how that looks. So now in the second term, in place of that whole square, we can say this is actually the Inradius lowercase r. So now the second term is going to become 2 times r squared. In the next step, I'm going to bring the 2 times r squared to the front and then take the common factor out of the 2 other terms. We have a nice common factor there. The common factor would be 4 times r squared times cosine of b. And then in the next step, what I'm going to do, in place of b, I'm going to write pi minus a plus c. Because we know that a plus b plus c is equal to pi radian, so b can be replaced with pi minus the sum of a and c, kind of like this. And we know that cosine of pi minus any angle is equal to negative cosine of that angle. So this expression can be written like this. Wherever we had cosine of pi minus a plus c, I have written that as negative cosine of a plus c. And now if we take negative 1 out of the third bracket, then we are going to have the expression like this. The positive 4r squared became negative 4r squared because we took out a negative 1 from within the bracket. So all the terms inside the bracket became positive, and the positive 4 times r squared became negative 4 times r squared. And in the next step, I'm going to expand cosine of a plus c. And if we do that, then the expression going to look like this. And there you see, within the bracket, the second term and the third term, they're going to cancel out each other because one is positive and the other one is negative. So we're going to be left with something like this. And now if we rearrange the factors in the second term, then we can write it like this. It would be 2 times r squared minus 4 times r squared times cosine of a times cosine of b times cosine of c. And what is this value, by the way? Well, this is actually hi squared, because that's what we have been calculating so far. So this is hi squared. Now to find the value of hi, we have to take a square root on both sides. So the value of hi is going to look like this. It would be square root of 2r squared minus 4r squared times cosine of a times cosine of b times cosine of c. Here the lowercase r is the inradius of the original triangle, uppercase r is the circumradius of the original triangle, and of course the angle A, B and C, they are the three interior angles of the original triangle. And that's exactly what we needed to calculate here, the length of the line segment HI. This brings us to the end of this video. Hope everything made sense. Thank you for watching. See you in the next video.